Okay, now this is practice paper 2, question 13. Okay, over here, Susie has a toy duck she uses to play within the swimming pool. Alright, so we will expect this toy, right, it needs to be waterproof, it can float, and also should be flexible, okay, because you can squeeze it, like this toy duck. Okay, so which of the following is most suitable for material to make the above toy duck? Fabric, no, because it will absorb water and hence it will not be able to float. Metal also cannot because it won't be able to float. But some of you will be saying we can construct a toy duck using metal and inside is hollow. Hollow means inside there's air. So maybe it can float, but metal generally they are quite heavy, so it may not be able to float that well. Okay, and some more it won't be flexible. Okay, paper cannot because it's not waterproof. So the best answer is actually rubber. Rubber is waterproof, and if you construct a toy duck like this, being a hollow duck, it can float, and also you can squeeze it. It's flexible. Okay, can bend. Okay, so our best answer is 4. Question 14. 4 sheets of materials W, X, Y, and Z. They are weighed individually before we put inside the 4 beakers here, and they all have equal amount of water. Okay, so you can see after 10 minutes, right, the sheet was weighed again, and their masses were recorded in the table below. So you have the mass at the beginning, they all have 8 grams, and after 10 minutes, you can see that the material, some of them, the weight is unchanged, like for W, it's still 8, so the change is 0. For X, the change is 15, so 8, if you take 15 minus 8, you can see the change is plus 7. Okay, for Y, the change is plus 10, and Z, the change is plus 12. So we try to see the smallest change, which is W, and the biggest change. So this 0 change means there's no water being absorbed by the material, therefore this must be waterproof. W is waterproof. And for Z, it's the most absorbent. You notice I would use the word most, okay, because it gains the most amount of water, okay. Because from the table we can see that the mass changes the most. So which material is most suitable to make a tent that prevent people from getting wet? So this material to make the tent must be waterproof because you don't want people to get wet. So answer must be W, okay, option number 1. Okay, question 15. Velu had 2 sheets of materials, X and Y. They have the same size and thickness. So he folded both as shown. And he noticed that X can fold easily compared to Y. So what conclusion can Velu make? Now, if you fold easily means you can bend, alright? Bend easily. Alright, the word fold here, we should be associating it to bending, okay? Linking it to bending. So for option number 1, lighter, this whether it's heavier or lighter, it has nothing to do with bending. Okay, so don't choose 1. Option 2, material X was weaker. Whether it's weaker or stronger is related to strength. Not whether you can bend it easily or not. Okay, so we don't choose this option number 2. Okay, and option number 3, material X was more flexible than material Y. So this one flexible means you can bend easily, right? That's talking about this flexibility. So material X can fold easily means it's more flexible. So option 3 is correct. Okay, let me put here option 3. And option number 4, can tear more easily. That is also related to strength. So don't choose option number 4. Okay, answer is 3. Whether material X can tear more easily, you remember we talked about strength means if the material is stronger, means it can support more weight without tearing, right? Without breaking. So this word tear these few words tear more easily is actually linked to strength. So we don't choose 4. Okay, now question 16. You have this testing of the strength of materials A, B, C, and D by dropping the weight from a height of 1 meter. The materials were of the same size, thickness, and shape. So take note, everything are the same because we want to have a fair test, but there's only one change variable here, which is the material that we are using. So first material, you have A, and you take 40 times, right, of dropping of the 1 kg weight in order to break the material. Okay, so you drop 40 times, at the end, right, of the 40 times, the material A will break. So you look at the table, we try to look at the smallest number and the biggest number. So smallest number means you drop 18 times, then after the 18th time, right, it will break. So it's actually the weakest. 55 times here, then it will break. It's the most number of drops. So it will show that C is the strongest. So what could be a possible conclusion? So based on which one is the weakest, which one is the strongest, we know that B is weaker than D. That's definitely correct because B is the weakest. Okay, so you look at question option 2, A is stronger than C. A stronger than C, that's not correct because C is the strongest already. C is the weakest, also not correct. Okay, we know that C is the strongest. B is the strongest, also not correct because we know that C is the strongest. Okay, so answer must be number 1. Okay, question 17. Now the table shows the properties of 4 materials A, B, C, and D. If there's a tick, means it has that property. So if you look at the question first, based on the table above, which of the materials is more suitable for making part X of an umbrella for use on both sunny and rainy days? Sunny means you do not want light to pass through, so we can be shaded from the sun. Alright, or rainy days means you want it to be waterproof, so you can be kept dry, okay, by the umbrella. So first of all, you see which one allows light to pass through. You see A and C, you don't choose. So we cancel them, A and C. Okay, now for waterproof, B and D, they're all both waterproof. So okay, right? But there's still one more property we should be very concerned about, the strength. So B is stronger than D, because D here there's no tick. So you ask yourself, for umbrella, part X, you want the material to be strong or not? Well, answer is yes. Because if there are strong winds or heavy rain, if the material X is not strong, it will break, okay? So it will break easily. So we will choose B because B is strong, B is waterproof, and B doesn't allow light to pass through. Whether it can float or not is not the main concern, alright? So answer is 2, which is B. Okay, question 18. Now, which one of the following will the two magnets push each other away? Push means repel. Repel means light poles face each other. So you see this one, north and north, light poles, then they will repel. Okay, same for south and south. Now for these two, they are unlike, so unlike poles, so they will attract each other. Likewise for this, likewise for this. So answer must be 1. Okay, question 19. You have a bar magnet and 2 objects. Okay, so you can see object X, right, is attracted to the bar magnet. So object X, we can we know that that there's this attraction happening, okay, between X and the bar magnet. But for object Y, there's no attraction. Okay, I don't know whether there's repulsion or not, but definitely there's no attraction. Okay, so what could object X and Y be? Now, for the choices we have copper and steel. So steel is a magnetic material. That means it can be attracted to the bar magnet. So I think object X cannot be copper. So you cancel away the copper and copper options. So it must be either 2 or 3 already. Okay, but now you see for object Y, if your object Y is iron, if this is iron, then iron is also a magnetic material. It should be attracted to the bar magnet. So it cannot be option 2. So answer will be 3 because object Y being plastic. Plastic is non-magnetic. It will not be attracted to the bar magnet. Okay, so answer is 3. Okay, now for 20, Eugene wanted to use a magnet to tell direction. So it's like a compass. So remember in class, we show you the compasses, and you can see that the needle, they actually can is freely suspended. Okay, they can rotate freely. Okay, so likewise, which one of these looks like that where the pin, the magnet, can rotate freely, right? Can turn freely. So this one, the magnet is already at the bottom, it's not floating, so it cannot turn freely. This one is out, cannot choose it, setup A. Setup B, this magnet is freely suspended, so it can turn freely, so this one okay. For C, the magnet is on a foam, and that means it like on a styrofoam, and styrofoam is floating on the water, so it can turn freely. So option C, yes, can, as in the setup C is possible. Setup D, magnet is on the table, cannot turn freely, so cannot choose D. So answer must be number 3, B and C. Okay, 21. Morgan set up an experiment with three ring magnates P, Q, and R of the same size, he observed that magnet Q was floating above magnet R. Okay, so maybe just clear this up. Okay, then I can explain. Oh, sorry. Okay, now let me explain. So we notice this we notice that Q is floating above R. That means there must be repulsion. Notice I put the arrow pointing away from each other. Okay, so there's repulsion. Repulsion means the poles facing each other, right? They are like poles. Now I don't know what are the poles, but I just put N first, okay, followed by S. Now because this is S already, so this side must be S, then the N. Then you notice for Q and P, they are touching each other. That means there's attraction. Alright, so attraction means unlike poles facing each other. So you have south here, then you have north pole here. Alright, so this is the original that I have written down for them. Okay, then he rearranged the magnates and observed the following. So now you notice for magnet P, Q, and R, now they are all attracted to each other. Alright, so which one of the following explain how Morgan rearranged the magnates? So you have to use the elimination method. You have to try out first one, second, third, and fourth. So we try the first one. If you flip P only. Now if you flip P, that means from NS now become SN. So you try. Okay, so we write down option 1. Okay, option 1. Now originally, right, you have NS, okay, then SN and SN. Okay, this is before. Okay, then after that, this is after. So if you flip P only, so this one is P, Q, R. So if you flip P, it will be SN, and the rest should be the same because they didn't flip any of them. Okay, now you observe these two these two poles facing each other, it should repel. Alright, and also these two sides facing each other, they are like poles, they also should repel. Alright, but you look at the diagram, they are not repelling each other. Okay, that means option 1 is wrong. Okay, so option 1 is wrong. Cannot choose option 1. Okay, doesn't work. Okay, now for option 2, you have to try it out. So for option 2, okay, let me just erase this. Okay, now for option 2. Okay, option 2, they say that they flip magnet Q only. So your R is still the same. So if you flip Q, it will be S, then N. Now the rest should be the same. So this is after. Right? So do we have the same scenario here where they are attracted to each other? Now you see the sides facing each other. Okay, this is attract. Okay, good. This one can. Okay, then what about this side? This is repel. Alright, so cannot already. So option 2 is wrong. Okay, because they should all be attracted to each other. So option 2 is not right. So I'm going to remove this. Okay, now for option number 3. Now option 3, he flipped P and magnet Q. So R is still the same. Now flip P, so it will be SN. He flipped Q, so it will be SN. Okay, so this is option 3. Now you see between the two magnets, this is attract. Okay, and this one also attract. Alright, so we can see that option 3 is correct. Okay, so if you try for option 4, right? If you try for option 4, you notice that it will not work. Okay, so we have answer to be number 3. Okay, maybe I'll show you for option 4 and see how it is. Okay, this one option 4. And this is after. So we have a flip of Q. So Q will now be SN. And he flipped R as well. So this is NS. But P he didn't flip. So we stay. Stay the same. Now you can see that this part is repel. Okay, and this part also repel. Alright, so cannot. So option 4 is out. So the only answer is 3. So this question, using the elimination method, you can try it out and you can see that option 3 is the only possible answer. Okay, now for question 22, you got a maglev train. It's a special train which does not have wheels and it travels much faster compared to a normal train. So by making the train an electromagnet, now electromagnet is like you can actually switch on and switch off the magnetism. Alright, so they say the maglev train is able to remain above the track without any contact. So you have the train, you have the track, that means there must be some repulsion. So which one of the following statement is able to explain how the magnets are able to keep the maglev train above the track while it is moving? So it must be light poles that repel. Alright, it cannot be the other 3. So here they say unlike poles that repel, that's not true because only light poles facing each other will repel. Okay, 23. You have a runner using the stroke method to make the magnet out of an iron rod. So the iron rod can attract 4 paper clips. Now what should he do if he wants to attract more paper clips? So you want to attract more paper clips, you can stroke the rod more times, but it must be in the same direction. Okay, so you see here, they stroke using a knob in this direction. This is anti-clockwise. Okay, so must be in the same direction. For option 1, change the iron rod to copper rod. That's not right because copper rod is non-magnetic. So we cannot even use copper rod. Okay, so it's out. Use a button magnet instead of a bar magnet. No, it must be a rod. Okay, must be a they say use a button magnet instead of a bar magnet. It cannot be a button magnet. Okay, it has to be a bar magnet like this. Okay, where it's long, but more importantly, this button magnet that they are talking about, we don't even know whether the button magnet is a stronger magnet than the bar magnet or not. So we don't choose this option number 2. Alright. Option number 3, change the pole of the magnet after each stroke. This is definitely not correct. You're not supposed to flip the bar magnet from North Pole to the South Pole. If you use a North Pole, it must be North Pole facing the rod, and then you stroke it downwards. Then when you lift it up, you have to use the North to go down again. Okay, so do not change the pole of the magnet after the stroke. It must be kept the same. So answer must be 4, where you stroke the rod more times, okay, in the same direction. Okay, question 24. Pupils were challenged to build an electromagnet using the coil of wires, batteries and iron rod. So they came up with 4 setups by changing the number of batteries and the turns of the coil. So we understand that if you increase the number of batteries, you will increase the strength of the electromagnet. If you increase the number of coils around the iron rod, you will also increase the strength of the electromagnet. So based on this understanding, the more batteries we have, okay, you see 3 batteries compared to 2 batteries, and here they have the same number of turns, 20 turns and 20 turns. So I will say C is actually will give a stronger electromagnet than D. But now you look at A and D, they all have 2 batteries, but this has 20 turns and this one only got 10 turns. So D must be stronger than A. And compare A to B, 10 turns versus 10 turns, they are the same, but this one has more batteries. So A will give a stronger electromagnet than B. So I rank them, this is first, second, third, and fourth. So answer will be 3. Alright children, that's the end for practice paper 2. Please do your correction and annotation. Thank you.